Hello everyone, welcome to Projects with Gaurav, and today we are going to build a new machine learning project which is email spam classifier, and we are also going to deploy it as an API using Flask. So by the end of this video you will learn how to pre-process your email data, how to train your machine learning model, saving and loading your trained model in Python, and you will also learn how to use Flask API for real-time spam detection. So, not wasting any much time, let's hop into our code editor. So, this is our project folder, email spam classifier YT. So, this CSV file you can find in the GitHub link below. There you can find the whole project code also. So, first we will install the necessary dependencies. So, we will need a pip install pandas, nltk, sklearn, and job. So these I have already installed, so I'm not going to run this command again. So let me remove it. And now let's import all the dependencies we need in our file. So for that, first we will create our model.py file. This will have our model and it will help us in training the model. So here are all the dependencies that we need. So we have imported pandas, nltk, sklearn, joblib. After that, we will load the data. So for loading the data, we are going to use cd.read csv, then the file name and in one encode. And let me show you the file. Here you can see we have category and message. So I have renamed them as label and message I have with small m. Now we will convert our labels to binary. So for that, I'm going to use this function. Simply, I'm going to map every ham equal to 0 and spam equal to 1. And I'm also going to drop any nulls, not a number, everything. So you can also check, let me show you first. So if you check df.shape and after this also print df.shape. So save it and run Python file. In starting, it might take some time. So here you can see we have shapes of both before and after processing. So let's remove this. After this, we will reprocess our messages. So this is the code I'm going to use. So what this code is doing, first it is downloading all the stop words from NLTK. What are stop words? Stop words are any words like this, as, are, I, or any stop words which don't add much meaning to it. Like stop words have the definition that the words which don't add much meaning for model during text processing. So there are many stop words you can check on your own also. So this we are getting for English language only, and we are also getting the stemmer. I'm using Potter stemmer here. You can use any other stemmer also. Then I'm going to make this function where I'm lowering every text. I'm converting it to lowercase. Then any special characters I'm removing like at the rate or anything like that. Then extra spaces is also removed. Then every word, because the message will be like this. This is a message. It will be a complete string. So every word needs to be divided. So words are split, and after splitting, I have checked, sorry, not converted. I have checked whether the word is a stop word or not. If it is a stop word, I don't need it. And after doing that, I have rejoined them over a space. So this function is applied on every message in our this in our data, or you can say our pandas data. So a new column is generated. Df processed message equal to df message dot apply preprocess text. You can also say using df dot shape. So initially we had two columns. Now we will have three columns after preprocessing. So run it. See, it downloaded the stop words and it also checks the stop words are up to date every time. and we have a third column. So remove this, save it. Now we will convert our messages into the vectors, or you can say into numerical vectors. So this is how we are going to do it. I'm using TF-ID vector, TF-IDF vector, sorry. Here we have imported it here. And what it is doing, it is converting the text into a numerical form which can be processed. Because after pre-process, or you can say after processing from this pre-processed text function, the code might, the string might be like this, like click here, no more. Like click here to no more is converted into click here, no more. So this needs to be converted into numerical form. This is what it is doing. It is converting the preprocessed text into the numerical form, and the labels are also separated.
Now we will create train and test sets and also train our model. So first we will split our data, this vectorizer data, into train and test sets. So I'm using 80% as training and 20% as test. So this number that should be between 0 and 1, and I'm using random state equal to 42. You can use any random state, so it's just a personal choice. And after that I'm using the multinomial NB model. Also you can use some other models like random forest and any other model you can think of. Also there are some models using neural networks like LSTM or BERT models, or you can use Hugging Face. But those models sometimes take a lot of time to get trained. So decide accordingly that what you need and how much accuracy you need and how much training time you can afford. So that are some considerations we have to make when we are training a machine learning model. So it is just a simple application, that's why I'm using multinomial NB model. Now after training we will evaluate our model. So we will first get the predictions on test set, and then we will compare the test set and the actual predictions we had. This These are the actual predictions we had and these we predicted. So I'm using this accuracy, I'm just doing some string manipulation here, and I'm generating classification report. It will give us precision, recall, accuracy, everything. After this, we will test our model on some customized messages, or you can say some more examples. So these are some examples I'm using. So here we are just making a function where we are going to pre-process the text because text will be in raw form and our model needs the pre-processed text. So that's why the message is pre-processed, vectorized, the prediction is generated, and then the answer is returned. And I'm printing that. Lastly, we will save our trained model. So how we can do that is using joblib. So what I'm doing is I'm making pickle files and saving two things. First is the vectorizer and second is the model. Why vectorizer I'm storing? Because vectorizer is the first step. So you can think of it as a blocks. First, your message will go into vectorizer. After that, the pre-processed message, it will go to the model and then you will get your prediction. So that's how we are going to do. Again, I'm loading them back just to see that our files were saved properly. It's not like there are some errors, because if there is any error, this code will catch it. So now our code is complete. Save it and run it. So it might take some time, it will be updating some packages. So you can see the accuracy, it is 97.76%. So it's a good accuracy for our application. And we can also see the precision, recall, F1 score, and support also. So like classification report gives you a lot of metrics, so it's good. And also here you can see on our test examples, it is giving us the output, and after saving the model and reloading that particular model, we are also getting an answer. Again, this answer you might say is not correct or it's a correct answer. It depends on how you see the spam messages, and it also depends how was the data quality on which the model was trained. So there are many things that affect the model accuracy. Now our model is complete. Now we will move on and make this model into an API. So for that, first close this file also, and make a new Python file named app.py. First, we will import all the necessary dependencies. So I'm importing Flask, request, and JSONify, then joblib, NLTK, then our vectorizer, and this is used for regex operations or regex functions. And then we have the Flask app. So this is just the initialization of a Flask app. If you know anything about basic Flask, you will be able to recognize it. Even if you are not familiar with Flask, just remember that this is the starting point of the Flask. If this is not there, your Flask application or your Flask APIs will not work. So keep that in mind. Then we are going to import our files which we saved in our model, our classifier file and our vectorizer file. And I have also imported the stop words. After this, we will specify for which language we need the stop words and also our preprocess function. So this is the same preprocess function as we used in our model. Let me show you. See, this is the function and here the same function. So you can copy it. It's not a big deal. Now we will be creating our API. So how I'm creating it? I'm creating a route called predict, and this method will be post. Here you can define different methods like post, get, put, it depends. So I'm using post for now, and now I'm defining the function. So this is how you do it. Let me show you. This app we used here, we are accessing its function called route, and then we are setting the route and with what methods you can access that particular route, then what that route should do or what is the processing that particular route must do. So this we define in our function, which is predict. So first it is getting the data, and then we are getting the message from the data, because in post we send our data using JSON. So if there is no message, it might happen there are some errors or message is not in the JSON file. Anything can happen. So we will return an error, and these are the error codes. 404 is the most famous one, and then 400, that invalid request. Then there is 200, which means okay. So there are many different codes. You can also check it. It's very easy. Then we will pre-process our message which we got from our JSON file. We'll convert into a vector, the TF-IDF vector. So for that we will need the vectorizer. See, we loaded the vectorizer here. So this is why it is needed. After vectorizing, we got our message which we can feed into our model. Then the model will take the message and we will get a prediction, and we can return the result in a JSON file, or you can say a JSON object. And then this is just the boilerplate code for the Flask. So save it and run it. So it might show some warnings like it is a development server. Don't worry about it. You should see something like this running on link localhost 5000 or 127.0.0.1:5000. So this is the localhost address, this part. So now our API is active. So I'm going to test our API endpoint using Postman. There are many other options also, but I'm most comfortable with Postman. So what I'm going to do is I have created a collection, and in that I have created a testing area with prediction request. So here I have typed the link. This is the link we got in the server, or you can say in the terminal, and this is the endpoint. Wait, yeah, this slash predict, which we defined in our function. And here you can set many different types of methods. So get, post, put, patch, delete. So I'm going to use post, and here is the raw object, or you can say the JSON object. Here you have to select body and then raw, and then here you can select JSON, text, HTML, XML, anything. So select JSON here and then type this message or type this JSON object. Then hit send, and here you can see we got a prediction. We got 200 OK status. We also got that how much time it took. So it gives you like how much time it take for whatever operations it did. So socket initialization, DNS lookup. So it is not hosted, so it will not look up for DNS lookup. But if it is like in production, it's a endpoint, it will have a DNS lookup time. So that is also there. Then there are many things, but this is just network specific, so I'm not going to dive deep into it. But let me show you one more thing. Let's suppose there is an empty JSON object. Send it. We got the error message, and we also got the bad request error code 400, which we set in our code. So again, you can test different message. Click here to apply, send. You get a prediction. So now we have tested our endpoint also, that it is working properly. So that's all for this video. We will meet in the next one. Till then, take care and bye.